Hello everyone, my name is ANSHUL. I am physics faculty in Sri Chaitanya Gosala Center. Right. So this is our second lecture of the series Newton's law of motion. Right. So those who are new here, I recommend them to watch the first lecture of Newton's law of motion, where you can get it. Either you can get it in the I section or you can get it in the live section. Just scroll down, you will get one video, that is Newton's law of motion part 1. Right. So what we have discussed there, we have discussed about the Newton's law of motion and the first law of motion. Right. So here today we will learn about the rest of the two laws of the Newton's law here. Right. We will start with the topic, that is your fourth topic. Right. So I hope please watch the lecture 1 and then after only continue with this one. Right. Okay. So fine, let's start. So I hope so everyone of you knew about it. What is force? Right. You have learned all these things in the class 9. Right. So what is force? What is force? What you do when you slap someone? So that's a type of force, right? When you push someone, that's also a type of force. So what is force? That's a very simple definition. That is what? Push. What happened? Okay, wait a second. Yes. Let me change it. Fine. Okay. So what is force? That is nothing but push, pull, that change or tends to change the state of motion. What is mean by state of motion? I have told you earlier also in the last lecture. Okay, what is state of motion? There are two states, that is rest or a motion. So if you want to change the state of motion, that is if you are at rest, you want to move the body, right? If you are moving and you want to increase the velocity, right, you want to change the direction or you want to stop the particular moving object, then what you required is what? Force, right? So state of motion is defined by velocity. That's what they have defined. Okay, state of motion is what? You define it by velocity. So for any body, if you want to change the state of motion, so what you required is that you required one force, right? That's what the example I had given. If you are at rest, if you are moving with a constant speed in the same direction, moving with a constant speed but changing direction, moving with a non-uniform velocity, you want accelerated motion, right? So for all these conditions, you required what? More force. You required force. Yes, you required force. What force can do? Yes, you might have played billiards, right? So when you shot the ball, what happened? Right, that's what. You move a body, you stop a body, or you break a body. Yes, right. I can't break it right now, but what you can do is you can break something, right? If you have something at your home, do one thing, take it and break it, right? So that's what your force. Key, the force is required to break a body. Yes, that's good. So what next? Yes, what are next? It's required to change the direction. If something is moving, you push it, right, or you pull it. What happened? Something is moving in this direction and it move either leftward or rightward, right? To change the direction, you again required what? Force, right? To change the speed also. Right? If a car is moving or let us assume some vehicle is not working, what we people do? We push it, right? We try to push it from the back. So what we are doing? We are increasing the speed, right? So that's what, to change the speed. Or take any object, you compress it or you pull it. What is happening here? You are changing what? Size. You are changing the shape and a size, right? So that's what is the requirement. That's what a force can do. I hope these very simple points are clear to everyone, right? 6 point, right? Let's move to next one. That's a very simple. Yes, tug of war. Everyone is applying force here. One is applying force. These people are applying force on the right hand side, and yes, these people are applying force on the left hand side, right? Is it? Sometimes you might have seen none of them are moving. even though they are applying force. So yes, force is what type of quantity? It's a type of vector quantity, right? It's a type of vector quantity. We have a two type of quantities, scalar and vector, right? So force is what type of quantity? Vector quantity. It means whatever output we see, right, that output of that physical quantity depends upon two things. One is direction and second one is what? Magnitude. One is direction and second one is what? Magnitude. Yes. So how we can understand this? See, direction. If I apply force in this direction, what you will see? This pen will move in this direction. Yes. If I apply force in this direction, you will see a different type of output. See, the different type of event you are observing when you are applying force in two different directions. So that's why whenever you observe something different output or something different result when you change the direction, right? So that's a vector quantity. And second thing, if you apply a small force, something will happen, right? And when you apply a large force, what will happen? You will see something else. So your observation will change. See, your observation will what? Change. So what does it mean? Ki the force is a vector quantity. What is vector quantity? It's a something which depends upon two quantity. What is that? One is magnitude and second one is what? Direction, right? So force is a quantity which depends upon what? Direction and your what? Magnitude. I hope you have understood the point, right? Fine. Let's move to next part then. I hope you are noting it down everything, right? See, just by watching a video, things will not work, right? Take out your copies, right? And start writing down everything. And I want your doubts in the comment section, right? For every single minute, I want your doubt. Write the minute of the video, right? If you are live, comment it now. If you are watching this video later, then just note down the minute. Okay, at this minute you have a doubt and write it down in the comment section. Okay, yes, I have this doubt. We will try to clear all your doubts. I hope you'll do this, right? So take out your copies, start writing down the notes. It will help you a lot, right? Okay, let's move to the next. Okay, so force is a vector quantity and force have some certain effects, right? So I have one question here for you guys, right? So just pause the video. If you are live, comment down, right? If you are watching it later, read the question and explain me, tell me what will be the answer. Is it yes or no, right? Yes or no. What is the question? Can I move in the curved path, right? Can I turn my car? Can I move in the circular motion? Can I rotate something without applying any force? Yes or no? Yes. Just tell me. Yes. If you can comment, it's well and good. If you are watching it later, pause the video and comment in the comment section, right? So what will be the answer? So very simple, right? So my answer is what? Yes? No. It's a no, right? You cannot move in the circular path without applying force, because see, we know that velocity is what type of quantity? Vector quantity, right? Velocity is what type of quantity? Vector quantity. If you want to change the direction of the velocity, you need acceleration, and for this acceleration to change the velocity, we need what? Acceleration. And for the acceleration, what we require force. So very important point here, right? For any body to change the direction, we need what? Force. For any body to change the direction, what we required is what? Force. Yes, that's it. So my answer is it possible for a particle to describe a curved path if no force acting on it? So it's not possible. It's not possible. Even in our solar system, we have a sun and your earth. it's circling in the elliptical orbit. So what force is there? Yes, we have gravitational force. Yes, we have what? Gravitational force here. Gravitational force. It's a gravitational force which is helping Earth to rotate around what? Sun. Yes, even the moon is revolving around the Earth, right? It's all because of what? Gravitational force. Gravitational force is helping. Okay guys, due to some technical error, my mic got turned off, right? So we are again starting from this slide, so that you just skip it for next 10 minutes, right? Because of some technical error, my sound was not audible, so I am repeating the whole part again. Is it now audible now? Right now I think it is pure live, right? Okay, fine. So fine guys, I think I'm audible to everyone. Do comment me once again so that I can understand, you people can hear me. Just give me a thumbs up or okay, yes, audible to everyone. Fine. So let's come to the point again. Sorry for this small technical error. Let's move. So we were here. So we have discussed about the forces. Okay, what is force? So now in the physics, what we do? We divide our whole forces in the physics into 4 parts, right? First one is a gravitational force. Second one is a strong nuclear force. Third one is a weak nuclear force, and fourth one is a electromagnetic force, right? So you have heard about, I think, this one in the class 9. In the class 9 you have heard about this gravitational force, Newton's law of gravitation. You might have heard acceleration due to gravity word. So these all terms are coming from this fundamental force, gravitational force. This is one of the most basic and fundamental force for in the whole universe, right? Everywhere it is present, right? And so what is this? Let's understand what is this gravitational force is. So you might have learned about this. If there are 2 point masses, see, understand one thing. Physics is only applicable for point masses. Physics is only applicable for what? Point masses, right? Nothing else. For us, we all are what? Extended bodies. We are group of point masses. Physics is not applicable for us, right? We use mathematics to apply the physics. So remember this gravitational force. Gravitational force, according to Newton, he said if there are 2 point masses, then there will be a force between them. Yes, there is a force between you and me also. Yeah, is it so? Yes. From where you are, I am in Vijayawada, right? My mass is 78 kg. Okay, what's your mass? You can calculate, you know your mass, right? Wherever you people are. So everyone knew, okay, what is a force formula? G m1 m2 by r square. You can place all the values and you can actually calculate the force between you and me, right? See, it's not this distance, okay, this is a screen distance. We are talking about actual distance, right? You might be somewhere, right? So what you can do is just apply this, okay, and do comment me the value later on in the comment section. Okay, what is the force between you and me? My mass is 70 kg. I am in Vijayawada. Wherever you are, you can check the distance, right, with the help of Google Map, and you know the value of G. Just get it from the net. You just place it here and do let me know the force between you and me. Yes, that's a great. So force we can calculate for any 2 bodies, right? Although whatever the value you will calculate will not be exact. Why? Because am I a point body? No, I am not a point body. Are you a point body? No, you are also not a point body, but still we can apply approximation. We always learn approximation physics, right? Okay, so great one, right? So yes, gravitational force. Gravitational force is also termed as universal force. It's applicable everywhere, every single point in the universe. It have a force, gravitational field. Yes, it has to be. Gravitational force is a very long distance force, very long distance force. Is it gravitational force is there between Earth and Sun? Yes, it is there. Is it between Pluto and Sun? Yes. Is it between one end of the galaxy to the another end of the galaxy? Yes, it is. Yes, so gravitational force is applicable everywhere, right? It's a very long distance force. But there is one problem with the gravitational force. Gravitational force is a weak force. What do you mean by weak force? Understand it. Just think about it. Okay, if this gravitational force is very strong force, what would have happened between you and me also? If I just think about it, there is a switch. I turned off the forces, gravitational forces, and now all of a sudden I turned it on, and the gravitational force is a strong force. So what will happen between you and me? There is a strong gravitational force, and what will happen? We both will get attracted to each other. Our distance will decrease. Just think about it. If the same thing will going to happen in the universe, what will happen? The universe will going to collapse. That's why, see, the nature had developed, created this gravitational force as a weak force. There is a reason behind it, right? There is some logical reason. We cannot dig all the details because we have not created the gravitational force, but we try to understand it, right? So gravitational force is a very weak force, and it's a long distance force, right? Okay, great one. Yes. Next one, gravitational force. We have done the formula. Let's talk about the nuclear force. Where is nuclear force? Where you find nuclear force? Can you comment me down? Can you comment me, people? Yes. Gravitation, nuclear force. Where you find nuclear force? If you are watching it live, comment me. Right, and if you are watching this video later, pause the video and then let me know where you find the nuclear force. Yes, is it between two electrons? Is it between two protons? Yes, it is there. But in the nucleus, nuclear forces are only present in the nucleus. Do you know what is the size of the nucleus? What is the size of the nucleus? The size of the nucleus is 10 to the power minus 15 meter. Oh my God, 10 to the minus 15 meter. I'll give you one idea about it. Okay, what is 10 to the power minus 15? Your thickness of the hair is 10 to the power minus 6 meter. It's almost 1, 2 or 6 micron. Right, this is micron. So just assume it. Okay, how many? 10 to the power minus 6 divided by 10 to the power minus 15. So this many nucleus can be settled in the one hair, right? One strain of hair, right? So see, the size of the nucleus is very small, and the nuclear force only exists in what? Nucleus, only nucleus. If you keep two protons, and nuclear force exists, there is a nuclear force between all the nucleons. What do you mean by nucleus? Anything inside the nucleus. That is your proton and neutron. All are what? Nucleons. If you keep two protons outside the nucleus, there is no nuclear force. If you keep two protons inside the nucleus means there is one region which is very small. If you keep it there, then yes, there is a nuclear force. Even there are two positive charges. Between two neutrons also there is a nuclear force. So now nuclear force are of two types. They are of two types. One is weak nuclear force and second one is strong nuclear force, right? There are multiple type of nucleus. You might have heard about uranium. You might have heard about thorium, right? They are unstable. They are unstable radioactive elements. Why they are radioactive elements? There is a reason behind it, and these reason, the explanation of all these can be done with the help of what? Strong nuclear force and weak nuclear force. I hope you are getting this right. So we have a two type of forces, nuclear forces. We have a one is strong nuclear force and one is your what? Weak nuclear force. Strong, and these forces act between what? Proton and neutron and psi. Okay, do you guys know what is the size of the atom? Yes. See, size of the atom is 10 to the power approx I am giving the approx value. It's changed a lot by the for the hydrogen atom size is different, for helium atom size is different. I am giving the just a approx value, that is nothing but 10 to the power minus 10 meter. It is also termed as 1 angstrom. 1 angstrom, the size of the atom, size of the radius of the atom is 10 to the power minus 10, and size of the nucleus is 10 to the power minus 15. Yes, that's what your next. Yes, let's come to the next one. That's your weak nuclear force. We have already talked about it. Okay, weak nuclear force exists in the nucleus only. Weak nuclear force exists in the nucleus only, right? And they are very short range. They are very strong. See, weak doesn't mean it is weaker than gravitation. Weak here means ki it is stronger than gravitation, but it is weaker than a strong nuclear force, right? So these all forces are exist in the nucleus. Now we have a third type of force, electromagnetic force, right? What do you mean by electro? What do you mean by electro? Charge and magnetic, magnet, right? So you might have learned this in the class 10th. The forces between two charges is termed as electrostatic force, Coulomb force. The forces between two charges is termed as your what? Coulomb force. And when forces between two current carrying wire, is termed as your what? Magnetic force. Even between the two magnet is termed as magnetic force. But after the progress of the physics, we have understood, you might have done this Oersted experiment, right? Maxwell experiment. These are the people who proved that electrostatic force and magnetic force are not two different quantities. They are the same. Only the way of observing them is different. So that's why these are the same. Just like you are the same person, but when your grandfather calls you, you are the different entity, you are the different person for him, right? For your friend, you are different. The relation between different people is different, right? That's the same case. It's the same thing, but for the different person, it is behaving differently, right? Why it is behaving differently, that all you will learn in class 12, but after all research, we have understood these all are what? Electromagnetic force. We name it as an electromagnetic force. One is electrostatic force and second one is your what? Electrodynamic force. This is mid-range. Gravitational force is a long distance force, nuclear force is a short distance force, but electromagnetic force are mid-distance force, right? Gravitational force is a long distance force, but it is weak. Nuclear force is a short distance force, but it is very strong, and electromagnetic force are mid-range force and their capacity is also a mid-range, right? So I'll give you one task for this thing. Just try to find out if you change whatever the gravitational force right now acting between you and me, right? Somehow if I change the formula, and if I change the gravitational force between you and me without changing anything, if gravitational force between you and me changes by 0.1% or 0.2%, what will happen to this universe? Just try to find out and do comment me, do give your answer in the comment section. Right? Okay, great. I hope you people are getting this, right? If understand, guys, if you are getting any doubt, just note down the timing of the video if you are watching this video later and comment your doubt with the timing in the comment section, right? Okay, let's move to the next part. Okay, so we have one more force. Okay, do one thing, you people, do one thing. Just namaste. Are you feeling something? Yes, you are feeling something here. Yes, this is what? Normal force. We name this force as what? Normal. Do you know the meaning of normal? I am not talking about that normal, right? I am talking about normal of the mathematics. If you know, there is a tangent and perpendicular to the tangent is termed as your what? Normal. So that is what the normal. Force between two contact surface. There is one force in which direction? Perpendicular to the tangent, perpendicular to the surface. That's why these forces are termed as your what? Normal forces. These forces are termed as your what? Normal forces. Yes, this one, namaste. This is your what? Normal force, right? You slap someone, right? So you will feel something. This is what your normal force. Whenever two body comes in contact, you feel normal. Yes, see here, compress this. You will feel one force here, one force here. So this is what? Your normal force. This is your normal force. Yes, right? Say namaste. Say namaste. Everyone, yes, say namaste. I hope you people are getting this. What do you mean by this normal force? I gave you one very interesting fact about it. We'll discuss this later, okay, why this is. But normal force is a type of electromagnetic force. Normal force is what type of force? Electromagnetic force. Can you tell me the reason why normal force is electromagnetic force? See, understand. Our body is made up of atom, right? Our body is made up of atom. Every atom have a proton, electron, nucleus. So when you touch them, there is some type of attraction or repulsion between the layers of the atom. It means this force is because of the attraction or repulsion force between the electron and proton of the atoms. And I have told you just now, any force because of the electron, proton, charges is termed as what? Electromagnetic force. Yes, so that's why normal force is what type of force? Electromagnetic force. And what is normal force? Why it is named as normal force? Because when you touch any surface, the force is always perpendicular. This is tangent, and perpendicular to the surface is termed as your what? Normal force. Perpendicular to the surface is termed as your what? Normal force, right? Okay, great. Next one, I hope you people are getting this. What is this normal force? Yes, frictional force. When you feel cold, rub it, everyone rub it. Are you feeling hot? Yes, this is what? Friction force. When you rub two surface, because of unevenness of the surface, there is one force generated, and that generated force is nothing but what? Again, frictional force. For this we have a whole chapter. We have a whole chapter on this frictional force. We'll do it in the detail, okay, how to calculate the frictional force. But right now I'm just giving you the idea about this. What is frictional force, right? So frictional force, again, what type of force it is? We have divided this into our whole force category, whole force into a 4 part: electromagnetic force, gravitational force, strong nuclear force, and weak nuclear force. Is it a gravitational force? No, no. Again, it is because of the interaction of the two surfaces, electron, proton of the two surfaces. That's why again frictional force is what type of force? Electromagnetic force. See guys, whatever we are learning, these are the theoretical question in the NEET exam. Yes, whatever we are doing right now, right, you can get a theoretical question over there. Okay, what is the type of the frictional force? It's a type of electromagnetic force. Why we have this electromagnetic, why we have this frictional force? Because of the roughness of the two surface, because of the roughness of, this is a general definition, right? About the detailed one, we'll do it later, right? Okay, let's move to next one. Let's move to next one. Yes, that's a. Okay, next one, contact force. Just like we have divided forces into 4 categories. What are these? Gravitational force, what? Electromagnetic force, strong nuclear force and weak nuclear force. Similarly, on the basis of contact and non-contact, we divide forces into 2 categories, that is your contact and non-contact. So you tell me, normal force is what type of force? Contact or non-contact? Yes, it is what type of force? Contact force. Frictional force is what type of force? It's a contact force. Gravitational force, non-contact force. Magnetic force, non-contact force. So yes, contact force, when two body comes in contact, they are very close to each other, and because of this closeness you feel some type of force, is termed as your what? Contact force, is termed as your what? Contact force. Yes, that's what it is. So normal force and your frictional force are what? Contact force, and if I take them combined, we name it as a contact force for this particular surface. If I rub this, then during this I am having 2 forces. One is normal force and one is friction force. So the combination of these 2 forces, we are naming it as what? Contact force. We are naming it as what? Contact force. Yes, great. I hope you are getting this. I hope you people are getting this. Yeah, do comment me, yaar. I'm not enjoying. Yes. Okay, great. Let's move to next one. Let's move. Yes. Can anyone tell me what is the direction of normal force in this case? I told you normal force is always perpendicular to surface. So yes, see, where is the normal force? One normal force here. Who will apply this normal force? This one. And one normal force here. So yes, the contact force between these 2 surfaces is termed as your what? Normal force. Yes, I hope clear. Okay, next one, tension force. You have a rope right now? Do you guys have a rope? Do one thing, stretch it. Or you have a rubber band? Do you have a rubber band right now? Right, so stretch it. You will feel some type of, there is some type of force is there inside this string. That force we are naming it as what? Tension force. That force we are naming it as what? Tension force. Okay. Tension force. Can you push it? No. It will get slack. But when you pull it, you feel it. So that's why, see, it's always pulling in nature. It's always pulling in nature. So tension force is always what type of force? Pulling force. Tension force is always what type of force? You can only pull if it is what? Rope. But if it is a rod, then in a rod you can compress it, you can pull it. So it depends upon material. But if it is a rope, then the tension force, the type of force, just I am giving you the feel. Okay, what is this tension force? The tension force what you get inside the rope. Or right now here, if I twist my arm, you will feel some type of force here. One is normal force. I am not talking about normal. Inside you will feel some type of force. That force is nothing but what? Tension force. Right? Tension force. Again, what type of force tension force is? Gravitational force? No. Electromagnetic force? Yes. It's again because of the change in the orientation or compression between the layers. If you have a rod, there are multiple layers in the rod. You compress it, you will feel force. You stretch it, you will feel force. You have a rubber, there are atoms of the rubber band. You compress, you stretch it, you will feel force, right? You compress the rubber, you will feel force. So why it is so? It is again because of the atoms in the material. So again it is what type of force? Electromagnetic force. It's a what type of force? Electromagnetic force. So that's it. Yes. Yes, see when this man is pulling, so this man is applying force on the wall, and this wall is also applying force on the man, and this force generated inside the rope is termed as your what? Tension force. This force inside the rope is termed as your what? Tension force. Great. Next one, it's already discussed, non-contact force. Gravitational force is what type of force? Non-contact force. Even though we are not in connection, I don't know you right now, right? But still we have some type of force between us. So that is nothing but the gravitation, non-contact force. Without knowing you, I have one force. Yes. Non-contact force. Yes. So every one of you have a weight. You know, when you go to space, you feel weightlessness, right? So just try to find out the reason why you feel weightlessness, right? You all have a gravitational force. You all are feeling gravitational force. When you go up in the building using the lift, you feel some heaviness. When you are coming down, you feel some less weight, right? So just try to know, okay, what is the reason. So gravitational force is a reason why we are feeling weight. See, right now in the legs you are feeling some pain, you are feeling some force. Why this force is there? It is because of the gravitational force. Right? So just try to understand, okay, what is the reason behind the this weight and how it is working. Gravitational force is what type of force? Non-contact force. And magnetic force is what type of force? Non-contact force. Nuclear force, non-contact force. Electrostatic force, non-contact force, right? But here tension force, normal force, right? Spring force, these all are what type of forces? Contact forces. Friction force is what type of forces? Contact forces. But with contact force, they are also what? Electromagnetic force. I hope the story is clear to everyone. Okay, what we have discussed today. Today we have tried to understand what is force, and after that we have tried to understand what are the types of forces, how they are affecting us, and if I change the value by even 0.1%, what will happen to this universe, right? With some examples. I hope you all are getting this, right? If you are getting this, give me a thumbs up, and if you are getting again any doubt, then do write down your doubts in the comment section with a time of the video. If you are watching this video later, if you are watching this recorded session, right, and those who are new here, I recommend them to watch the first part of the video, that is Newton's law of motion part 1, where we have discussed about the first law of Newton's first law, right? In the next session we'll try to cover the remaining part, right? Till then, bye. See you in the next lecture. Thank you.